there! Welcome to Learn Math with Miss Anna. With me, Putu Meidyana Ardiyanti, with my last three-digit number is 047. In this video, I would like to share some knowledge for you that is very close to our daily life. Can you guess what is it? Maybe not yet, right? So before we dive into it, let us just start with a story. Imagine that this morning, our school is preparing for a big festival. Many visitors will come. There will be food booths, game booths, music performances, and prize stations. But suddenly, everything is messed up. Fruits are mixed on one table, registration papers are scattered, snack machines are not arranged properly. So, if everything is messed up like this, what should we do first? We might think to organizing them, right? And I think that organizing thing is the right thing whenever we face messy situation. But without our realization, in mathematics, there are concepts that talking about organizing things, connecting things, and giving rules to something. Those concepts known as sets, relations, and functions. Have you ever heard about it? Well, today we're gonna learn about these three chapters. Let us move to the first ones, which is sets. Okay, before we dive into it, let us start again with a story. Imagine that we are in a festival and there are some fruits like apple, banana, apple, orange, grape, banana to be repeated. And they are mixed on one table. And then we decide to group them neatly. One place for apples, one place for bananas, one place for orange, and one place for grapes. So now it looks clear and organized. Well, in mathematics, a clear group like this is called a set. So formally, a set is defined as a well-defined collection of objects. Are you confused about this definition? Well, if you are confused, let's us dive into it. First, well-defined. What is well-defined means? So, well-defined means that the object can be defined clearly without any misinterpretation or ambiguity. So we can easily decide whether it belongs to the set or not. For example, when I ask you to list months in a year, you might say January, February, March, until December. So it is clear that this month belongs to this set. Then what if I say nice songs? You might be confused, right? Is Night Changes by One Direction belongs to this set? You might say yes or no because nice songs depends to one person's preference, right? I might say that Night Changes by One Direction is a nice song, but it doesn't mean that you must say the same like me. That's why nice song cannot be considered as a set because it gives many interpretation and it's very subjective. Okay, that's all about well-defined. And now let's move into the second highlighted word in the definition, which is collections. So, collection means a group gathered together. For example, a collection of number, a collection of students, a collection of books. But remember, the objects that are collected must be a well-defined objects. What is a well-defined object? Let us remember again about well-defined that we are discussed before. Okay, that's all about the definition of set. Well, every set has elements on it, where elements is the item inside a set. Okay, if you're confused, let us just move into the rules to represent set. The first rule is sets are usually written using curly brackets. As I said before, every set has elements on it, and the elements of the set is written inside the curly brackets. You can see the example here. The second rule is sets are usually named using capital letters. For example, we have a set like A, where A is an even number less than 10. So the set of A represent as this, where the elements of A is 2, 4, 9, and 8. The third rule is elements are separated by commas. For example, whenever we have a set where its elements are apple, banana, and orange, we can divide or we can separate each elements by commas. We can see here. But what if there is no separation symbol like comma? So we're going to be confused because whenever there is no separated symbol, we might think that is the elements are apple, banana, and orange, or the element is just one, which is apple, banana, orange. That might be confusing. That's why we need commas to separate each element. Okay, do you get until this part? If yes, let us just move into the next rule. So, whenever we say an element is belong to a set, we use this symbol. This symbol is read as belongs to. For example, like we have a set of A, and the elements are 2, 4, 9, 2, 4, 6, and 8. So it means that 4 belongs to this set. To this set, or 4 belongs to the set of A. What if we would like to say that an element is not belong to a set? So we use this symbol. It is read as doesn't belong to. So, for example, like we have an element where its elements are 2, 4, 6, and 8. Then it clearly means that 4 doesn't belong to the set of A. Okay, the next rule in a set is order doesn't matter. So whenever we have elements whenever we have set where its elements is 1, 2, and 3, it exactly means it exactly the same as whenever we write down as 3, 2, and 1. So order doesn't matter in a set. The next rule is repetition doesn't matter. So whenever we have a set where the elements are 1, 1, 2, 2, and 3, we can simply write down as 1, 2, 3. Okay, so we don't need to repeat them. We just write down 1, or we write down the represent of each element. That's all about the rules in writing sets. So now we are moving into important terms in a set. The first important term is cardinality. Cardinality is the number of distinct elements in a set. So it simply means that how many elements that there exist in a set. For example, like we have set A, where the elements are 1, 2, and 3. So it's clear that the cardinality of set A is 3. The second term is universal set. So universal set is a set that contains all the elements or objects that being discussed. For example, whenever we are in a class that are discussing about colors in rainbow, so the universal set is colors in rainbow. And then another important terms to be known is empty set. So empty set is usually written by curly brackets that has no element. Empty set exists because there are some sets that has no elements at all. For example, like set of months with 32 days. We know that there are no months that contains 32 days until now, but we don't know in the future. So it means that set of months with 32 days is an empty set. Okay, that's all about important terms in set. Now, our question might be how to represent a set. So there are some ways to represent set. For example, the first one is descriptive method. In descriptive method, a set is represented by describing the characteristics shared by its members. So we are not writing down all the elements, but we are writing down the characteristic of the elements. For example, set C, where the elements are odd number less than 6, where the elements is actually 1, 3, and 5. Different from descriptive method, enumeration is we are listing all the elements. But whenever the elements are too many or too many elements, we can use three dots. That means and so on. So we can see the example here. We have set of A and also set of G. We can see that sets E is called finite sets because these sets or the elements in the set are bounded. And we can easily know the cardinality of the set. While set G is called an infinite set because it is using and so on symbol. So we don't know what is the last element of the set, and we don't know how much or how many the cardinality of the set is. That's why it's called as infinite set. Another way to write down about set is using set builder notation. So in set builder notation, we are writing down or representing the set by symbols and notation. So there are some rules to write this set using this notation or using this way. You can easily read in this white paper, in this whiteboard. Sorry. So one of the example of set build notation method to represent a set is we can see here. We have set A where the element is x, where x is a prime number between 7 until 30. And we also have set B, where the elements are x, where x is an integer between 3 and 8. So you can see here, it's using notation. It's using belongs to, and it's also using rather than and less than. More than and less than. Okay, that's all about set. So we know that set is about organizing things, but sometimes we're not just organizing them, we are also giving them connections, or we also giving them relations. For example, let us just start with the story again. So there are three people or three students, where the first student is Ali, that is working in ticket booth, and the second student is Budi, that is working on food booth, and Clara working on game booth. So we know that each person and each booth has connections. Where the connection is Ali to ticket booth, Budi related to food booth, and Clara related to game station. So here we know that we can write down two sets. The first set is students and the second set is booth, where the student contains Ali, Budi, and Clara, and the booth contains ticket booth, food booth, and game station. And then whenever we make connection of it, it's going to be a relation. So formally, a relation is a set of ordered pairs that shows the relationship between elements of one set and elements of another set. So we might be confused about the definition, right? So what is ordered pair? An ordered pair is written as A, comma B, but don't forget using brackets, where the first elements come from the first set and the second elements come from the second set. We can see here in the example before. So the one of the relation happen here is Ali, comma, ticket boot, because Ali is related to ticket boot. That's about order pair. So it is clear about the definition of relation. There is an important notes. There is important notes in relation. So if in a set we know that order doesn't matter, but in relation, order is matter. So Ali, comma, ticket boot is different with ticket boot, comma, Ali. That is the important notes to be remembered. In relation, there are three things to be known. The first is domain. So domain is the first set or the started set. Let us see the example here. So first we have set of E where the elements are 1, 2, and 3. Here is going to be the domain. And the second one is codomain. Codomain is the other set that is going to be related to the domain. Where in this situation, the codomain is set B, where its elements are 2, 4, and 6. Suppose that we are going to make the relation is double 2. So the relation happening here is 1, 2, because 2 is double to 1. And then the next relation is 2, 4, because 4 is double to 2. And last relation is 2, 6, because 6 is double to 3. That is about the relation. So we also know about range, where range is the elements of the second set that actually use. In this situation, the elements in set B or in codomain that actually use in the relation is 2, 4, and 6. That's why we write down the range is 2, 4, and 6. That is about relation. And now how to represent relation. The first is through order pair. A relation can also be represented using order pair by pairing elements from set A with elements from set B. You can see the example here. The second way is using a row diagram. So in a row diagram, we make the diagram of each set, where in this situation, we can see that the yellow one is the domain set and the green one is the codomain set. After we are making the diagram of the sets, and now we are making the connection of it. For example, -2 is connected with 1 and 3, and etc. That is about arrow diagram. And then there is also Cartesian graph. We know that Cartesian coordinate has two elements, where the elements are x-axis and y-axis. So we can also make the relation into graph. For example, like first we see the dot, where the coordinate of the dot is 3, 1, where 3 means that we walk 3 units to the right, and then we walk again 1 unit to up. That's why whenever we use Cartesian graph, we make the coordinate or the pair into x, y. Okay, that's all about Cartesian graph. We can also write down the relation using table. So in this table, we make two columns where the first column is the domains and the second column is the codomain. So we can see one of the relation happening here is -2, 1. That's all about ways to represent relation. So here, we're gonna talk about notes on relation. So what is considered to be relation? The first one is one element may connect to many elements. And the second one is some elements may have no pair. So whenever they are in these two situation, it means that it is still considered as relation. That's all about relation. But sometimes we're not just organizing them and connecting them, but we're also giving them rules. So here is set as functions. Let us just start with story again. Imagine that we are going to buy drinks in drink machines. So there are rules here. Whenever we press the A button, we're gonna get juice. When we press the B button, we're gonna get water. And when we press C, we're gonna get milk. So here we can know that there is rule. That's why it is considered as function. So what is actually a function is? A function in mathematics is a spatial relationship among the inputs or the domain and their outputs or the codomain, where each input has exactly one output and the output can be traced back to its input. We can see first domain. So domain is the set of all possible inputs or the starting value. In this situation, we know that the input is A, B, C button. And then the codomain. So the codomain is the set of all possible outputs or the result after applying rule. So in this situation, we know that the codomain is juice, water, and milk because after we give rules to A, B, C button, we're gonna get juice, water, or milk. That's why it's called as the codomain. But remember, in a function, each input must have exactly one output. So now let us just consider what is a function and what is not function. We can see in the first picture. So here we're having diagram where the diagram has two sets. The first set is A and the second set is B. So we know that A is going to be the domain and the output or the codomain is B. But in this picture, we know that it is not a function because one domain element is paired with more than one element. So we can see here, one of the element in the domain has two pair or has two pair in codomain. That's why it's not a function, but it is a relation. Okay, the second one, we can see that it is also not a function because one domain element has no pair. So in a function, the domain or the elements of the domain must have one pair in the codomain. That's why it is not considered as a function, but it is a relation. Okay, let us see the third picture. We can see that it is a function because each domain element has exactly one pair. You can see here, one of the element in set A is paired into one of the element in the codomain. So it is a relation and also a function. So it is clear that a function means that all the domains or all the elements in the domain must have one pair in the codomain. Okay, what do you think about it? Do you think it is still considered as a function? The answer is yes, because all the elements in the domain has one pair in the codomain. Even though the codomain even though not all the elements in codomain is paired into the domain, but it doesn't matter. The first thing we have to see is the domain. That's why the answer is this is considered as a function. Okay, that's all about what is function and what is not function. And now we're gonna move into types of functions. There are some types of function. The first one is the inductive function, or usually known as one-to-one function. An inductive function is a function where each element is the codomain. In the codomain is paired with at most one element from the domain. We can see in the picture here. The second type is surjective function, or usually known as onto function. A surjective function is a function where every element in the codomain must have at least one pair on the domain. So it means that all elements in the codomain must have at least one pair on the domain. So there is no element in the codomain that is single. Okay, the last one is bijective function, where a bijective function is a function where every element in the codomain has exactly one corresponding element in its domain, and no element is left unpaired. So it means that bijective function must fulfill the rules of injective function and surjective function. Okay, guys, now we're moving into function notation. So functions are usually written as f(x). This means that function f acting on x. So x is becoming the variable here, and x is changing. For example, like we know that the relation of the function x is x plus 2. This means that whenever we take any input of x, then we add 2 into it. That is the rule of the function. Okay, now we're moving into function as ordered pair. So we can see that function is also can be represented into ordered pair. For example, like if we have fx equal to x plus 1 and the domain is 1, 2, 3, then the relation happen is 1, 2, 2, 3, and 3, 4, because x here is becoming the domain, and the codomain is fx, or usually known as y. And then we make the ordered pair, where each pair means like input and output. So the input is x and the output is fx. And now the function can also be represented into graph, and it is different. It is different depends on the function, or depends on the type of the functions. For example, like whenever we have linear functions, we can see that the graph is becoming like here, like this. And it is different between quadratic function, rational function, and logarithmic function. And we're gonna discuss more about it next to the next class. Okay, here we're gonna learn about how to draw a function graph. The first one is we have to choose several x values, where x values here is becoming the domain or the input. And then we substitute into the functions. After that, we will find the y values, where the y values is becoming the outputs. After that, we write coordinate points, where the coordinate points is x, y. After that, we plot points on graph paper, and we connect smoothly if needed. Okay, guys, that's all about our study session today. We already learned about set, relation, and function. Okay, that's all from me. Thank you. Whenever you have any question, don't forget to ask me on the comments below. See you guys.